Today in this video I am going to introduce about our project whatever we have made, that is a Arduino based digital MP3 player. So now without wasting any more time, let's start. This is the presentation flow that we are going to follow about throughout the presentations, and these are the topics that we are going to discuss throughout the presentation. Okay, now let's discuss one by one. First of all, I will introduce what were our key objectives to make this MP3 player. Well, the first one was it should be a user friendly device. It should be a cost efficient so that anybody can purchase it, and it should be completely customizable, and that is an incredible features of our product. That means you can customize the UI, you can customize the hardware components, even you can upgrade the memory, microcontroller, everything on this board. And the MP3 player should also be sustainable. That means one can use it for a longer time. Now, before going too deep into our presentation, the general question that may come into your mind, that is, in this 20s era, why MP3 players? Because a smartphone can do better than this? Well, to answer the questions, I have created a chart where you can see the direct comparison between a smartphone and a MP3 player. What a MP3 player can provide better than a smartphone? Well, I am going to discuss one by one. The first of all is, it is a distraction free device. See, a smartphone has an internet connectivity. So that's why whenever assume that you are listening to a music, and whenever you are listening to a music, there may be a certain time that you are getting notifications, you are getting several advertisements, etc. etc. But where MP3 player doesn't have any internet connectivity. So that's why a pure music lover will be able to experience a distraction free music. And the second one is quality sound. See, a MP3 player is intended to improve and give a better sound experience. So that's why the MP3 players, inside the MP3 players, the high quality audio decoder circuitry are used. A smartphone can also provide the better sound, but not as much as MP3 players, because a smartphone has been made to do some smart works, not only listening to music. And a good battery life also, because a smartphone battery drains within 6 to 7 hours, where an MP3 battery standby around 1 day, 2 day, etc., depending upon the battery capacity. And storage capacity is also important thing. See, inside a smartphones, there comes smartphones along with a very large amount of storage. But remember one thing, the inside a smartphone several types of applications are there, several types of files are there. So if you calculate the average storage for MP3 files, you will be understand that the storage capacity of an MP3 player is better than a smartphone, because some MP3 players in the commercial market comes with expandable storage capacity also, where you can insert your SD card. That's the facility that we have also provided in our product, and you can expand your storage up to 32 gigabyte for our case, where you can store up to 8,000 music files of about 5 MB. That means about the 5 minutes of duration, and you can enjoy the listen experience. Now let's discuss the features of our product. Basically, this is the clear picture of our physical product. Now let's discuss what are the features of our product is going to provide. Our product has a OLED display for clear visual navigations, for a clear understanding whatever the operations you are going to perform, either it is a pause, play, previous track, next tracks, etc. etc. Our MP3 players has a expandable storage capacity where you can insert the SD card starting from the 2 GB to 32 GB, where you can store up to 8,000 songs. Our MP3 players have a digital battery monitor. Yes, there is a real-time battery monitoring. Whatever you see above the display, there is a 7-segment display. There are even 3 segment displays. The 3 7-segment displays helps to monitor the real-time battery during playing the MP3 files. And this player is completely reprogrammable. You can customize and reprogram the UI, you can change the hardware, you can upgrade it, you can do anything. There is complete flexibility about the reprogrammability. And it's the important one that our MP3 players we have also provide the 6 equalizer support. Equalizers means audio equalizers. Depending upon the taste of a music listeners, you can switch between 6 EQ modes: normal, pop, rock, jazz, classic and bass. If you are a bass lover, you can use the bass mode. If you love to listen the classical music, then you can change your taste of the music into the classic modes and etc. etc. But during making this project, we faced some problems. So it's very important to discuss about the problems, whatever we faced before making the project and whatever the challenges that we solved. Well, the first question was about the proper selection board. The general question, it's a general problem for every project, whatever you are going to make using a development board. What board? There are plenty of the development boards are available, plenty of microcontrollers available in the commercial market. But based on our requirement, we have sorted what is the actual board that we are going to find out. So let us see the requirements and selection of the boards one by one. Our first requirement was we want to make this project on the Arduino based. So that's where there are 4 options with the Arduino. Now with which board we should go with. Our second criteria was low cost. If I talk about the low cost, then I think Arduino Mega is out of the competition, because a single Arduino Mega board cost around 1000 to 1200 rupees. And portability was also a big factor for our project, because it's a MP3 player. Anybody can use it by keeping it inside the pocket. So coming to the portability point, Arduino Mega and Uno both are out of the competition, and Nano and Pro Mini sustained. And if I talk about the memory size, the Mega and Uno memory size is very good, and Nano is also quite sustainable. But talking about the Pro Mini memory size, it comes with only 1 KB of flash memory, so which is very less. As our code for this, at the coding portion you will see that our code of this project is very large, and that was unable to fit inside the memory of the Pro Mini. Along with that, the Pro Mini has one more disadvantage, that it cannot provide the proper power supply. So if I want to satisfy all these criteria, then there is a clear picture in front of you. I think you have understood. Yes, right. We have selected Arduino Nano for our project. Now there is a problem. To power up Arduino Nano, we have to select a battery. What is the battery type that we should go with? There are plenty kinds of battery available in the market. What type of battery we should choose? Yes, this battery chart will help us to select the proper battery. You can see a energy density chart of several kinds of batteries has been shown, and you can clearly see that a lithium polymer as well as a lithium ion batteries are based upon the energy density, that is watt hour per kilogram. So however, we have gone with lithium polymer battery and we selected that we will use a 3.7 volt single cell lithium polymer battery. Now there was another problem arrived. We have selected the Arduino, we have selected the battery, and we cannot increase the battery because the portability was a factor. So the battery that we have selected, that is of 3.7 volt, and in the full charge it maximum it can provide 4.2 volt. But after some research I came to know that our Arduino Nano can run from 7 volt to 12 volt. That means the power supply that we should provide the Arduino Nano to give it an efficient run is 7 volt to 12 volt, and it's highly recommended to give the 9 volt. Now the 3.7 volt battery is alone was insufficient to provide the 9 volt power supply to the Arduino Nano. Then we have to use the converter, that is the boost converter. MT3608 is the boost converter module that we have used here. This module has two incredible features. That is, number one, this module can provide a constant 2 ampere power supply, and number two, it's a very small size. Even the length of the module is along 1 inch. But there is a problem with this module also. Okay, we have made a module, we have introduced a module to supply the 3.7 volt power from the battery directly to the Arduino, but the module has some disadvantage, some discredits. See, this is that module, this is exactly that module in the simulator. If you provide the input voltage, that is the battery voltage, greater than 2.5 volt, then we can constantly regulate the output voltage 9 volt, and the Arduino will be happy because the 9 volt is the regulated voltage, that is the main requirement for the Arduino to run. But if you provide a voltage 2.5 volt, which is very obvious, when you will use the battery voltage will start discharging. So whenever the voltage of the battery will be below 2.5 volt, then the boost converter will boost up the voltage up to 28 volt, which is the maximum default voltage of this boost converter. Even you cannot regulate it. So what to do, and what will happen with Arduino? Well, I think you have understood this. But don't worry, there is a solution. The solution is, it's a very general solution. Along with the battery, we will use the digital voltmeter, a DC voltmeter, and whenever the voltmeter voltage will become below the 3 volt, it's the time to charge the battery. I think I have selected all the components, and along with it some more components that are required for this project. Let us see this. These are all the components those are required during this project. And for communication channels, I have used these 4 components, that is male-to-male jumper wires, 2 types of header pins, and a mini USB cable for programming the Arduino Nano. Okay, now let's discuss all of these components one by one. First of all, introducing the Arduino Nano. It's basically a development board, and it comes with a mini microcontroller that is Atmega 328P, and it is all the features has been shown here about Arduino Nano. If I talk about overall, that it comes with a 16 MHz crystal clock which is operated on 5 volt, Though the recommended input voltage is from 6 volt to 12 volt, it can consume current around the 40 milliampere. And if I talk about the memory, then there is a flash memory of 32 KB, which was more than sufficient for our project. Okay, MT3608 module. This is a boost converter that we have to use along with the battery to power up the Arduino. And these are all the pin diagrams of MT3608 module. If you provide the input voltage from 2 to 24 volt, you can regulate the constant output voltage from 5 volt to 28 volt. And it can also provide the 2 ampere maximum current, though the 1 ampere is recommended. Though you can avail the 2 ampere by using a heatsink. Then the next one is a DF player mini module, which is the main component for our project. Here we will use the expandable SD card, and to read the files from the SD card we need this module, and this is all the pin diagrams of this DF player module. Now the next important thing is 1.3-inch OLED display for visual understanding. The 1.3-inch OLED display comes with 4 pins: VCC, ground, serial clock and serial data. It can be operated using a serial communication between Arduino and 1.3-inch OLED display. Now to charge the battery, we have used the TP4056 charging module. And the most important thing here is, as we have using the LiPo battery, the LiPo battery are recommended to safely charge and discharge. So that's why this module is here. We can charge the battery along with a cutout voltage 5.5 volt, and the maximum output current that you can avail from this charging module is 1 ampere. And let's introduce how our project works. I have created a basic diagram here through which you can understand what's actually happening inside the total assembly. Well, our mother component is Arduino Nano, and assume that we have programmed the Arduino according to our desire. So to run the Arduino Nano, we need a battery, but along battery is not sufficient. For that, we need MT3608 boost converter, which will continuously give supply voltage around 9 volt to the Arduino Nano. Now, after getting supply, what Arduino will do? Along Arduino Nano, 2 more components are connected. One is 1.3-inch OLED display, another one is the DF player. It will start signaling 1.3-inch OLED display and DF player. And one thing that I want to mention here, that is both 1.3-inch OLED display and the DF player will take the supply from the Arduino Nano. After getting the supply, the DF player will turn on and the OLED screen boots up. But it will not start running the MP3 files as long as you haven't attached a SD card here. If you insert a SD card, it will enter its main menu through which you can run the MP3 files. But to operate these things, I have used the 3 kinds of push buttons: left, right and select. Using these 3 buttons, you can navigate between the MP3 files. But I think you have forgot one thing, that is the total supply is driven by a single lithium polymer battery. So during using, the battery voltage will discharge. Now to charge the battery, I have used a TP4056 charging module, which will start charging the battery. Well, this was all about our circuitry internal working. Now I will show you a simulation in the Proteus 8.11 professional software. In this simulation, I have shown exactly how you can operate this total thing. Here you can see that I have created the circuit, The same circuit I have also created in the PCB that I will tell about later. You can see that using the left navigation buttons, you can navigate between the menus. Yes, this is the menu section. Using the select button, you can enter into a menu, and in this menu, in the music menu, you can play, pause, previous track, next track, etc. You can do with the music like that. I have play the music number or track number 1, and another menu you can go with by using the select button, which is the main menu. In this menu you can change the volume as well as the equalizer. Okay, here you can see that I can decrease the volume, and the maximum volume that it supports is up to 30. From 0 to 30 level of volume it can support. And as I have already told, it also supports 4 equalizer starting for number 0 to number 5. Okay, so there is a voltmeter you can also see that is here to continuously monitor the voltage. Okay, that's all about our small simulation, and let us see what is the actual product that we have made. This is the actual structure of the product that we have made, and the structure of the product is totally enclosed by a transparent acrylic sheet, which gives it a cool look. Now the most important one, now I will show you how we have worked throughout these 5 months, and what was our work plan, and how much cost that we have to carry with it. You can see this is the total work plan from starting of the first week from the January and ending at the 3rd week of May. Step by step we have gone forward and we completed our project in time. And this is the component list along with the predicted price and the actual prices. Though from our predicted price, our actual price is quite low. Now let us see, using some softwares we have made it, because we have programmed it, and we also have used some software from creating different kinds of things. So it's very important to introduce you what are those softwares that we have used in this project. The first one is the most common software that you have to use any kinds of Arduino based project, that is the Arduino IDE. Using this we have programmed our Arduino in C++ language, and along with it we have also used the Proteus. Whatever the simulation that you have seen, that is on the Proteus 8 professional software, where you simulate the circuit before final assembly, so as to check if there are any kinds of more difficulty occurs with this or not. And another software that we have used, that is Easy EDA. To design the PCB I have used it. Yes, you guessed right, I have designed a custom PCB here. So upon this PCB I assembled each and every component so as to avoid the clumsy or the meshy the wirings and the wirings mistakes also. That's something like loose connection and etc. And we have also used the freezing software, where we basically assemble total circuit on the breadboard. Using the breadboard you can also design PCB, but it's not recommended. The programming language that we were used, that is 2 languages. Number one is C++, which has been used here to program the Arduino Nano, and the Python application that we have also made it, because to insert the MP3 files in the DF player you have to follow some rules, follow some naming conventions. Now to avoid these kinds of misconception, these kinds of ambiguity, I have used a Python application where you can insert your MP3 files, and the Python application will help you the renaming the files according to the serial number. Okay, now is there any pros and cons? Definitely the MP3 player comes with several kinds of features. Our MP3 I am talking about our MP3 players. It has some pros, but along with this I will also show you what are the cons and is the cons are recoverable or not. Let us see. You can see our MP3 players have four kinds of advantages. What are they? The first one is it's completely customizable. Yes, it's right. The second one is it's the expandable storage where you can insert the SD card of maximum 32 GB. Due to the DF player we have we can introduce to these kinds of advantages, because the DF player itself supports from the SD card starting from the 2 GB to 32 GB. Now it's a very compact form because the length and the width and the height are 110 mm, 55 mm by 40 mm. So it's a very compact and can be easily be carried out using the pocket. Now OLED display is here also for a visual understanding. But along with it, there are four cons among them two of them is very important. Those are, number one is poor battery. As we have made this total thing a compact, that's why I am not able to provide the larger capacity battery. Using a single cell 3.7 volt and 430 mAh battery, you can avail the backup of maximum 2 hours only. And it's number two, the major con, that is fragile. As I have used a transparent acrylic sheet here, it's a very much fragile. If you hit it, it may be damaged, but it may be cracked. And along with this, there are two minor cons also that I don't think this is a minor, but avoiding this, you can also use the MP3 players. Those are, number one, single operation. Single option means you can only listen to the MP3 music along with the wired headphones. And the fourth option is the average audio. Now in this section, this average audio section, I cannot do anything because we are not able to change the audio quality or something like that, because the audio were directly coming out from the DF player. Maybe it's problem with my DF player also, but I don't think so. So DF player supports the high quality audio file, it says, but I don't think that this is a very high quality audio file, and whatever I have listened, it seems average quality, though it's a very crystal clear. Now let's talk about some important applications of our project. Where our project, this Arduino based MP3 player, can be used. Let us see it one by one. Our Arduino based MP3 player can be used for the home automation, because in the home automation you can customize your voice welcome, like welcome to this, welcome to that, something like that, welcome to our sweet home, just like that. You can insert your voice command in the SD card and insert the SD card in the MP3 files, MP3 player, and you can customize your home automation also. Yes, interactive art is very important application for this project. And educational tools, I have seen many kinds of students that those are most friendly to use the voice learning or voice teaching. That means something like, along the 100 students I have seen that 80% of the students like to listen the YouTube videos rather than studies the books. So that's why for listening to the audio notes and to save the audio notes, you can also use the MP3 files. For public announcement, you can also the MP3 player, and for entertainment purpose also, just like a toy, and to add different kinds of sound effects in the music, you can also the DF player which has been inserted in that MP3 player. And assistive technology is another main important and major application of these MP3 players. And the custom greetings that I have already told you, voice is quite similar with the home automation. You can customize your welcome tone, greeting tone, etc. using these MP3 players. And the last one is the very obvious. Using this player, you can listen to the audio files that you can use it a pocket size iPod. You know why all these applications are possible here? Because the reasons is it's completely customizable. Yes. Can we do some future enhancements? Can I talk about it? Yes. There are also 5 future enhancements that we can make, that we can upgrade, that we can do upon this to make it a more futuristic. Among of them, the number one is Spotify player. I can make this player as an online reference MP3 player. See, in this era, most of the people listen to online music. That means like post Spotify, JioSaavn, Gaana, several different types of online platforms for listening to music are available there. Now you can control your online platform, online music file which you are playing in the mobile phone definitely, but you can control everything for play, pause, previous track, next track, volume up, volume down using your MP3 player. But to do that, you need a Wi-Fi connectivity. That's why I have to come out from the Arduino and I have to use the ESP8266 module. I can attach a clock facility along with the MP3 player, because in the commercial market, whatever the MP3 players you can see, if there is a digital display, there might, I think most of the players comes with the digital clock facilities. Now there is also a facility that I can provide, that is MP3 along with the FM radio. The radio files that will be played, that will be from the online platform, because the direct radio communication is not possible here, because here we can provide only the one facility along one microcontroller, which is ESP32 microcontroller. Using the ESP32 microcontroller, you can make the IoT devices, I think you know, and this IoT facility will help us to fetch the MP3 files from the online radio websites. Now we can also do some minor enhancement. Those are Bluetooth connectivity, that as I have already told, one of the minor con was the only one option, right, that I have already shown you. This minor option can also be enhanced by introducing a Bluetooth module there, Bluetooth transmitter module there, where you can connect your Bluetooth earphones rather than a 3.5 millimeter wired earphones. It will be a great enhancement. And you can also introduce the speaker facility, that except using the headphone also, you can listen to music directly from the inbuilt speaker of the MP3 player. I think these are the 5 main advantages, 5 main things, 5 main future enhancement that you can do with this. Now if I talk about the conclusion, whatever we have learned throughout this scene, those are: our MP3 file comes with customizable functions. Yes, obviously you can customize anything, UI, hardware, upgrade anything. Our MP3 player also comes with problem solving, because using this project, throughout this project, I have introduced several kinds of problems, and whatever we have faced, and we have also cured from these problems. So throughout this project, we have also learned how to solve any kinds of unknown problems. Yes, hardware integration is also possible. DF player MP3 decoder module is there, so that's why we have successfully integrated the hardware, and we have successfully assembled each and every hardwares. So we have also learned how to integrate hardwares on the printed circuit board, and we have also learned along with that how to create a printed circuit board in EasyEDO website. Now programming skills, as we have used the two kinds of programming, that one is Python and one is C++. So I think the programming skill or the real application of the programming that we have already understood. Now the last conclusion is the protocols. During this project we have researched about the Arduino, and we have also researched about the communication between DF player, OLED display with the Arduino. And during this research we have been introduced several kinds of protocols like USB protocol, SPI protocol, I2C protocols, etc. And these are all the references that we have used to make this clear presentation. And that's all for today. Thank you for giving your patience to listening to the whole presentation. And there is a feedback form that I have provided here. Depending upon the several categories of the presentations, you can give us the feedback, because your feedback is really valuable. And if you have any doubt, you can directly ask me using this contact number, my mobile number, and you can connect me in the email also. All the doubts will be replied. Before ending, I want to make an important announcement. That is, the total video of this project will be uploaded in the tech channel. If you haven't subscribed my tech channel, please subscribe it so that you will get notified soon whenever I will upload the total video of this Arduino based digital MP3 player. So that's all for today. Thank you. Thanks for giving the patience. Have a nice day.